there are more differentiation rules that can help us take the derivative of a function without always needing to call the limit definition of a derivative. For example, the derivative of a constant is 0. The derivative of a function f of x plus a function g of x. So when you take the derivative, is just take the derivative of each function and you add them up. So derivative of a sum is the sum of derivatives. What about f of x subtract g of x? Well, when you take the derivative, is f prime of x subtract g prime of x. So one more rule that's helpful is when you have a constant multiplied by f of x, and then when you take the derivative, the rule tells you to just take the constant out. Okay, so k times derivative of the function. So we can take a look at an example of how to apply the rule. So let's say f of x, maybe not f of x, it might confuse you. H of x equals 2x cubed minus 3x plus 7. So how do we apply these rules to take the derivative? Now, one really simple thing that to keep in mind with is the sum or difference of function. When you take the derivative, basically, you are really doing it term by term. So what this rule tells you is that you can take the derivative one term at a time. So when we take the derivative of this h function, we really can just look at one term at a time. So the first term here is 2x cubed. So it's 2 times x to the third power. We use a constant multiple rule. Okay, so we just keep the constant 2, and then you multiply it by derivative of x cubed. Well, then you use a power rule, is 3x squared. Then you take a look at the next term, okay, is minus 3x. So, or you can think of it, okay, it's 3x. So you keep the negative sign. So what's the derivative of 3x? Well, the derivative of x is 1. So it's just 3 times 1. And what about the last one? Okay, plus 7. What is the derivative of 7? Is derivative of a constant is 0. So the derivative of this h function, if you simplify it, is just 6x squared minus 3. Now, the more you practice, the easier or seamless it is for you to be able to take a derivative of a polynomial.